if you have a function and your function has components f and g, and they're both differentiable, then, and also f of x is a composite, which would look like this. Would look like this. So it has components f and g, and it is also a composite. Then the derivative of f of x is given by the product of f prime of g of x times g derivative, or g prime of x. So that is the chain rule. So this argument stays the same. This turns into a prime, and then you also multiply it by the argument's derivative, the proof. So if you have the same situation, f of x is equal to f of g of x, then you just make that into an h of x is equal to f of g of x. You must show that x can be a constant of c. The way you would do that is h prime of c is equal to f prime of g of c times g prime of c. And that shows that c is a constant that can be plugged in at x. And this is the same thing as this right here, but instead of the f, it's an h, and obviously the c is plugged in for the x. And the f of g function, oh, that shadow was bad, okay. It has two parts, as an inner and an outer part. So if you have y is equal to, let me change colors for this, f of g of x, that is also equal to f of u. And this shows that this right here and this right here, these are your outer functions. And this shows that this right here and this right here are your inner function components. And now that we know that our function has two parts, outer and inner, we can see that the derivative of y equals f of u is the derivative of the outer times the inner derivative, which means y prime equals f prime evaluated at u times u prime, which, if you'll remember, is the same thing as h prime of x is equal to f prime of g of x times g prime of x. It's just, instead of g of x, it's u. So our first example is h of x is equal to 6x minus 2 cubed. So first we need to identify our inner and outer components. So our inner component is our g of x, which is this right here. So it is 6x minus 2. And our outer component is x cubed. Because h is composite, we can use the chain rule to differentiate it. And first we need to find our derivatives of these. So our g prime is just 6. I did not write that right. So our g prime of x is just 6, and our f prime of x is 3x squared, which is d over dx f of g of x, f prime g of x times g prime of x. So now we will plug it in. So this will end up being 3 times 6x minus 2 cubed times 6. And that is, this right here is this exact thing with our substitutions. So then we will multiply our 6 and our 3, and this will end up equaling, so I'm going to put d over dx of f of g of x, dropped parentheses there, didn't I? Will end up equaling 18 times 6x minus 2 cubed. That is our answer. So now we're going to do an example with a trig function. So first, of course, our trig function is f of x is equal to cosine cubed of x, which can also be written as cosine of x cubed. So first we identify our inner and outer function. So our outer, of course, is going to be f of x is equal to x cubed. And our derivative of our outer is f prime of x is equal to 3x squared. So our inner is, of course, g of x is equal to cosine of x. And our g prime of x is sine of x, because that's the derivative of cosine. So now we will plug that into the chain rule. So once we plug that in, it'll end up being 3 times cosine of x squared times sine of x. Just move where this squared is. So we can do 3 times cosine squared of x times sine of x. And there's nothing else we can really do there. But that is the answer. Just stop.